BCS, that is the foundation, right?
Yeah, sir.
Um, yes, of course. Why not? Yeah, you should be able to wrap it up.
Okay, sir.
If you can just if you can just tell me what you're exactly going to do, because I will be actually starting off another company anytime sooner, where we'll be focusing on this thing. We'll be focusing on career guidance
No.
and like career advice, basically.
Oh.
So,
And sir, to do the Edexcel O levels in the grade 8 also.
okay. So hold on. I do have a lot of tabs opened. So yeah, we have a so I have another company which is called Pick Course. So here this is a company where we basically give career advice for students who wants to kind of learn something new. So I can of course
Okay.
give you some ideas about where to go and where to start from, and so on and so forth. Okay.
Yeah, sir. Thank you.
Sure
Okay,
thing,
let's
sure
do
thing,
it.
no problem. Okay, so I think that day we actually started from the bottom, right? No.
Sir, that day, sir, we was like jumping up sort of because we thought of doing
Yes.
like the hardest ones. That's
Yes. Okay, so perfect. Where can we start? So, shall we? I think that day we went to the
sir, can we do from the space? Sir, can you explain that lesson, sir? Wait, sir. The lesson, not that thing. Wait, sir, I'm finding it.
yeah, sure.
Yes, that analog sounds and those things, digital and analog sounds, those things.
Yeah,
In from by
converting sound to binary. This part.
Yeah, so that's in that part, sir, I could understand like in sir, our teacher has sent sir, those answers and those some questions that she made for he from teams, and sir, like she told like what is analog sound, where sir, she told us like which in the which way that the analog sound would like would be like digital sound would be a good analog sound sort of.
Okay. Yeah. Okay. Yeah, we can do this. So, okay, perfect. Let's first check the question now. Here, I think I saw a question for this. This is the one. Okay, so perfect. So this is the question. Mehmet. So this is how it works. Let me make this a bit. No, let's keep it as it is. Okay. Let me quickly jump into the document, and then we'll see how it goes. Okay, so first of all, for your syllabus, Kenneth, we do not go over 4 bits. Okay, so there are multiple bit ranges where which is there. So for the moment, we are only going to talk about 4 bits. Okay, so that's the basic point. So this is known as the sample rate. Okay, now usually if you take a mp3 file or audio file, they can go up to about 24 bits. Okay, so that's a massive binary range, as you can imagine. Now 4 bits is just four binary sequence, no? Okay, so this is
Yeah, sir.
how it is going to work out. So now if you look at this one, so when it comes to sound, there are two different uh, ways where sound is categorized. So one is basically the time in seconds, and we call this the amplitude. Okay, so the amplitude is basically the vertical axis where it shows the sound waves. Let's say in this case the sound wave size. Okay, so the wave goes like this, and at the same time it goes across a certain time period. So that is going to be the time. Okay, so the horizontal axis is the time and the vertical axis is the amplitude. Okay, so now when we convert this particular value into binary, this is how it is done. Okay, so let's see the conversion now. Okay, so if we go back to the page number 79 where we did the binary conversion. So this binary number plus we had a binary conversion, right? You remember that conversion part we did, no? Right? So
Oh yeah, so that plus numbers.
exactly. So based on this particular factor, we have an option of calculating this. So it actually goes as, so in this case, we do not consider the time. Okay, we make a complex ending මෙතන ගොඩක් අය, so some people tries to get the time into the calculation, but in a real world scenario what it does is, what you need to think about is only about the amplitude. Okay, so amplitude in binary is basically you convert this amplitude value to binary. Simple as that. So now if you take this question what we have here, in this question this is asking the time is 0 and the amplitude and the 4-bit binary. Okay, so now when you look at this, what are the numbers? So let's start with the numbers. We have give me 1 second, Kenneth. Let me plug in my I do. Yeah, hold on. I have a.
Yesterday, sir, we started the exam.
Yes. Yesterday, even when you sent the message, I saw the message very late in the night, when my day ended at 3 o'clock in the morning. No problem, no problem. I saw the message, but that time it was too late to reply. Okay,
Yeah.
so okay, so let's get a pen and let's write this up. Okay, so now this is the amplitude. No, hold on.
Yeah, that ASCII, that conversion easy, that thing that's at all,
Yeah.
that easy waves. Almost now every class is asked me the method.
Okay. Okay, so super. So this is going to be the. Yeah, why isn't this drawing properly? Okay, let's see. Okay. So this is going to be the amplitude, right? So this one is the amplitude. So that means we start from over here. Okay. So that means the first value. So this is the time now. So time starts from 0, 1, 2, 3, 4, 5, 6 and 7. So this ends at the second, which is the 6th second, right? So first of all you need to do is first write the amplitude in binary numbers. So in this case, this would be 6, and here this would be 4, right? All the crossing points. So the first one would be 4, and what's the second?
For the second one, it is 3.
Perfect. And fourth?
And
the third 5. Okay, perfect. 7 and fifth one is 5, and then this is 2. Nice, perfect. Now since we got the amplitude done, now all we need to do is just write it in binary. So
No, that's easy.
Yeah, that's easy. So what is the binary for 6?
For this, the binary is 8 plus then it's 4. So sir, from the beginning, sir, it should go 1, 0, Wait, so I had to take a piece of two for all exam one exam. Wait, 1 8 4 2 1 A 1 what's it? 1 so for the 6 is then 2 then so 0 1 0 1
0 1 0 1. Is it?
0 1 0 1
හරිද?
it is coming as 0 1 0 1 wait so I'll check again
මෙහෙම ලියලා බලන්න. මෙහෙම ලිව්වම ලේසි. So you have 2. So you divide 6 by 2, remainder 0, 3. Divide 3 by 2, remainder is 1. Then you have 1. Then you divide 1 by 2. You again have a remainder. So that means it's 1. කියදෙන්න amount එක.
then the 0 0 1 1
Exactly. Yeah, 0. It is going to be.
Let's I'm gonna just put the phone here. And so first is 6, so we can minus 8 by 6, and so it is, then the answer is 3, 2, then so we are putting 1 at 8, 1, 0, and in 2, 1, because we minus 2, and 0, 1, 0, 1. 2 tens.
2 tens ද 1 එකක් ඉස්සරහට එන්නේ නැහැ නේද?
Yes. We can't put the things that are bigger, but the smaller ones. Wait, then sir, it is this thing. 0 1 1 0.
හරි. Yes, perfect. 0 1 1 0. Nice. All good. Then what's 4?
0 0 2 zeros at first, 1 and 0.
You have to write it other way around. So we count it from bottom to top.
Yeah, then say it should be 0 0 2 zeros at first, and 1 and 0.
Yeah, so that means 0 0 1 and 0.
That's it.
Alright, perfect. Then 3.
And the next one is 1 0 1.
3 is 1, honey. This is the number. Yeah, okay.
1 1 0 0.
1 1 0 0. Perfect. Then 5.
5 sir.
Since you know 4, 5 is easier.
1 wait. 1 0 1 0.
Nice, perfect. Then 7.
For that sir, we can go from
So
4.
now since we know 6, then in order to add a value for this, what do? You just add one more, right?
1 1 0.
Nice, perfect. Okay, then again 5, so we know what is 5 is. And then 2.
And 0 1 0 0.
Perfect. Nice. Okay, done deal. You got full marks. Maybe be careful with this thing, this binary calculation part. So try to remember this table. Make a මතක තියාගන්න අනිවාර්යෙන්. So for your syllabus, the maximum you are going to get is up to 16. So write this and practice. Just write 0 to 15 and practice the code, because if you practice this couple of times, it's going to be really easy. It's just going to be a walk in the park. So even I being in the industry for a long time, still I also, if I try to do the calculations in my mind, sometimes I also make mistakes. So what I do is I just write it. Even if you use your fingers to calculate, that is perfectly fine. Na? Nobody is going to judge you, just use your fingers. ඉතින් මම තාමත් සමහරවිට මොන හරි ආවම වෙලා මෙහෙම ඇඟිලි වලින් ගණන් කරනවා. It's okay ඉතින්. we have been
Yes, even I am still like this.
Yeah, it is no worries. No one is there to judge you, no? Okay, so that's the point. So so you might get this type of questions because now, since this question looks a bit hard, people tend to give you this. But then again, now you know it's really easy. It's just a matter of calculating this. Alright. So remember, we do not think about the time. So we do not think about the time. Only the amplitude matters. Got it?
Yes.
Okay. Nice. Then let's talk about this one. So a transistor is often described as similar to which household item?
Light switch?
Correct. Yes. And okay, so this is a true or false. The number of transistors in a modern computer is only a few hundred.
False.
Yes.
Almost.
Of course, yes, true. So, which of the following is not a digital audio device?
Digital audio device.
Digital audio device.
CD, MP, recorder, CD player.
I don't know. CD is also a digital audio. Ne? Winley, so this is basically the answer is a Winley record turntable. Okay, so a record turntable. Hey, let me show you. You guys will never.
Also, that thing there. Not that thing. I got that CD player.
No, this is a turntable.
Oh, so in those classic houses, they even have those classic things.
Yes, so you had so this says Winley, so Metin Parnea ko. We had like this old turntables with little.
So in those hotels even.
Wait. Have you seen one of these?
Oh yeah. We have like turn on
Yeah, exactly. You have to wind it first, and once you wind the coil, then it starts to play. Now we do have like latest models.
I did it in the hotel because they were like they kept it for an eye.
Okay.
And I was like went turning, and it went like crazy.
Yes. So remember, a Winley record turntable is that one. Okay. Then, which of the following is an essential device to convert audio?
Microphone.
Here that's the thing. There's a tricky. So this question is actually a tricky question. Now, which of the following is an essential device to convert audio? So, both of these.
The microphone.
Yeah, that's the thing. I think.
Oh wait, they are asking essential device.
Correct. So scanner off. Printer also off. Now, I believe, so according to the tricky question, I believe the answer should be the speaker. How is it? This says convert audio. So that means the audio is already there. So if you say convert sound into audio, or audio convert sound into digital, then microphone should be true. Got the point?
Ah, now okay, so like it is the other way around. So then they will give it like they would say the ball and they would give another thing.
Yeah, that's a bit of a tricky point, eh? I also didn't
Yeah.
expect to get that type of a thing. So it says convert audio, so that means it should be this one, speaker. Okay, then by increasing the number of recordings per second, what will happen to the sound quality? Okay, super. So let me explain you this with our design. මෙහෙමයි වෙන්නේ. Okay, now if
Then
you,
the quality will be higher.
yes, of course it is going to be higher, yeah, no doubt. So now this is actually known as the so we call this the sampling rate. Okay, so sampling rate means, now මෙතන if you take this one from 0 to 1, within this particular seconds, number of seconds, we have only one sample, one amplitude නේ මෙතන තියෙන්නේ. හරි. So that means it is basically just a single sampling point. So
Yes.
if you increase the number of samples, automatically the number of information which you can capture automatically goes up. Right? So when the number of information which you can capture goes up, automatically the number of details which you can capture also goes up. So in that way, the sampling rate increases, plus the quality also increases. So I'll show you.
That
Yeah,
in the sense, like the amplitude also changes, right?
amplitude is the one which is getting changed.
That means if the sampling rate is higher, the amplitude table is going to go like 0.1, 0.2, 0.3 like that, right?
Exactly correct. So now if you take let me show this. So there is a certain wavelength and the quality. Okay, super. So if you look at this one, this is a 48 kilohertz analog wave. So we measure the quality based on the hertz rate. Okay, so when you have a 48 kilohertz rate, this is how the sampling works. Hare. So that means when you convert it directly to a digital wave, see, these are the data points. Okay. Now when what happens is, when the sampling rate goes up, so when it goes up to 96 kilohertz, see, automatically the analog points gets increased. So that means the digital audio wave has much more quality. That's how.
So that's what we are doing those DJ, those softwares, even they are having like change the amplitude. Then when I change the amplitude, the thing is going more higher and getting more thinner.
And the file size becomes much larger.
Yeah.
So we have so the lossless. So normally this is how it works. So you know about MP3s, no? So MP3s have a 44 kilohertz 16-bit range, which goes up to 128 kilobytes per second, right? But we have this other audio type known as FLAC, FLAC. FLAC goes for 96K with 24-bit audio. Okay, and it goes up and it requires 1 megabit per second to basically read it. Okay, so this is why we do not use FLAC on the internet. No point, nobody can play this. So have you heard about this platform called Deezer? Deezer කියලා තියෙනවා platform. See, so Deezer is the platform. You can actually get a trial and listen to this. So Deezer is a platform where only focus towards like high-end audio. We call them audiophiles. Audiophiles means like people who love audio. So Deezer is a platform created for them where all these audio files they have is 96K 24-bit audio.
Then so who's going to use it?
People use it. People use it a lot. I also used to use it. I also used to
But
like pay and have that subscription. Now I don't use this because now I have 24-bit audio on Apple Music.
sir could use those DJ studio or something, and sir could combine two musics together, and
Yes.
sir could just change the things and make your own.
Yeah.
I just make my own.
Yeah, we used to do that a
No.
lot. Okay, so just to put the cherry on top, so Apple Music, they created one of their own audio codecs. So if like FLAC, Apple has their own thing, Apple Lossless Audio Codec. Okay, so this goes up to 24 bits, and
Yeah.
and you need to have a proper iPhone to listen to this music, plus proper internet connection has to be there as well, because one song is about 60 to 100 megabytes.
Oh,
Just one song.
no, sir.
Just
No
one song.
way, sir. Sir, that day, sir, when I got the internet, sir, I just checked my internet
Okay.
by connecting my server to a Colombo dialogue server, sir.
Okay.
I can't remember where it was, around like Gamba.
Okay.
I just connected my server, and my Mbps went like 21 Mbps.
Okay.
The downloading speed, the uploading speed was used like 10 and 6, around 10 and 6.
Uploading is limited anyway. That's true. That's true. What you said is true. Upload speed is
Answer we now, sir, in Sri Lanka, sir, you can order the Starlink. Those Starlink satellites, it is going to give you like 131 Mbps.
I already ordered one, waiting until that is getting delivered. Let's see how it goes.
I even told my mother to
Okay. So, okay, let's jump back. So, so the answer would be by increasing the number of recordings per second, what will happen to the quality? Obviously, the quality would be higher.
Higher.
Nice. Okay. Nice. Okay. Now, this is where we get things a bit complicated. Binary to binary. Not complicated. This is basically the easiest part when it comes to writing the answers. You just need to have the idea. Okay. Describe the number systems. Base 2 and base 10. What is base 2 and base 10?
Sir, base 2 is literally used in binary. Base 10 is used in denary.
Denary. Base 2 is used in denary, where we use that for basically day-to-day purpose, right? Okay, so how you need to actually write this in a proper way, where just make sure that you obviously use the wordings correctly. So when you write the answer for this Kemit, write it in a full form. Base 2 is used for blah 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 blah. Okay, so and then base 2 is used for write some examples in this, sorry. So you can, so the keyword is binary. Okay, let me try to write this and see. Cool. Binary ambo make a liana sahanamari.
Sir, do you write it from the mouse?
No, I do have I do have a pad.
Ah.
Okay, so.
Sir, I thought of like without having pad, having an iPad.
iPad is actually much better. Make a magula mara what happened to my What happened to my videos?
Sir, you are having some what? Something iMac or something, right?
I'm using a MacBook Pro.
Sir, can't you like bend that thing and just try it?
I don't know. MacBooks doesn't support it. May
Sir,
so
what if there is a ITS?
yes. May so your answer should be completely written like this. Binary users 0 and 1s. Okay. And base 10, you can write it as base 10. What's the word for this? What do we call this?
Denary.
Denary. Perfect.
Denary uses
Denary uses what?
base 10. Denary uses base 10 to represent a denary numbers.
Yeah, but then again, it's actually easy if you write 1, 2, 3, 4, 5, 6.
So we are going to get like a limited time, sir.
Yeah, I think. Come on now. Uses this number range. That's it.
And sir, literally in our school, sir, we can't do, sir, because
Why?
our children's pens are flying down, and they have to pick them out just to copy. They have to copy them.
Okay. So, okay. So, can you write this down? Did you already wrote it?
Yes, sir. I am going to write it.
Okay.
I like these days I did the IT. I'm gonna write this answers for it.
Yeah. Just take a second and write it down. Sorry. And we'll directly jump to the second one as well. So, complete the base 2 and don't mind my writing. It's a bit hard to write on this tablet.
Yeah, sir. Sir, answer it is like around 9,000 views.
Okay, so now then the next important point is complete the base 2 and base 10 to the power tables. Okay, now they have already given you the make it like they have made it easy. Right? So what is the number sequence? So since this is 2 to the power 6.
Sir, I know. From the beginning, from 1, from the beginning of 1, we can take 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6.
Exactly. So you have to write it nicely. 2, 5. No, there's a problem since I'm writing on this PDF that that takes as individual items. Now I can't literally write 4 without lifting
Yes,
the.
sir, do you have Microsoft Edge?
I do have Edge, yes.
So open it from that. So it allows you, right?
Let me try this on.
I never use it, but our maths teacher,
Okay.
she uses it. That's it.
Okay, let's see. How do you write?
So that is Chrome, right?
Yeah, but both are the same.
So from Chrome, sir, I don't know. But in Microsoft Edge, sir, they literally give you a bar here. So you can just take the
Is
pen
it?
from
That is on a smart board.
Yeah.
That is on a smart board, no?
No, sir. It is like this, no, sir. You go to the Microsoft Edge
Okay.
and you open the PDF that whatever you are going to open.
Okay.
And sir, when it opens, sir, it gives in a PDF form. And sir, in the top bar, sir, you can take the pen.
Okay. I will try it out. I don't have Edge installed. Okay, so this is clear now. So since the 2 to the power 6 is already given, we know that that is the maximum amount. So remember, this is 2 to the power 0, the last one. So this starts from 0 and goes until 6. Okay. So then what about this one? This is much easier. base
Oh
10.
yeah, so you have to like write what is that. In the first one, sir, from 1, sir, you can take 10 to the power 0, 10 to the power 1, 10 to the power 2.
Yeah. So this starts from 0 as well. And 1 and 2. Hari?
Okay, sir.
Okay. Nice. Okay. Now we jump into a bit of a difficult question. So now we have the denary number in decimal, and
Yes.
this is asking for the, so complete the values that would appear at the top of an 8-bit binary place value table. Okay.
Sir, shall I tell the answers?
Yes, shoot.
16, 32, 64.
Perfect. Awesome. Correct. Nice. Okay.
Sir, our brother gave me the sickness.
I was just going to ask you. I, okay. Are you okay to go to school?
No, sir, now, sir, I have the images on.
Okay. Alright. Then, now, this is another tricky one. Okay. So, here you have to, now here, Kemit, be careful because you have to show the addition. Okay. So, that means now here, this is in binary. No? This is in binary. So, the addition should be in binary.
That means, in the sense, that means the denary number is in the up. No, sir, you can just take 4 plus 32.
Yes. කියන්න බලන්න මේකට මොකද එන්නේ? What about this
4
one?
plus 32, sir,
No.
it's 36.
Yeah, 4 plus 32, 36. But this addition, they ask you to show it. Right? So, in an ideal scenario, you must write 1 plus. I can't draw the plus. No? Yeah, okay. 1, sorry.
If you
0.
add it, sir, I could like write it.
You can write on it, no? No worries, no worries. Come on, Shave. You know, you got the idea, no? Right? So this should be written as 0, 0 plus 0 plus 1 plus 0 plus 0 plus 1 plus 0 plus 0. Did the answer I told you correct?
Sir, I think we should add like 32 plus.
Exactly. No, like you will have to say that 0, 0 plus 0 plus 32 plus 0 plus 0 plus 4 plus 0 plus 0. So then you put the final answer as, so what would be the answer here?
36.
36. Perfect. Then what about this one?
That's 0 plus 0 plus 3 zeros plus answer 16 plus 8 plus 4 plus 2 plus
1.
one more answer 3 and 3 and 4 7 and 8 15 and 16.
No, hold on. So when you see this type of numbers, try to add it with the easiest. So no. Just don't write it on your hand. So let me show you an easy way. So look at the combination. So what are the easiest ones to calculate? So here 8 plus 2 is 10, right? You know that, no? And here this is 16, no? 16 plus 2, 4 is 20, right? 8 plus 2 is 10, 16 plus 4 is 20. So 20 plus 10 is 30, 30 plus 1.
31.
Yes. Don't try to add 16 and 8. But like, okay, so even if you try to do that, then what would happen is 16 plus 8 is 24. 24 plus 4 is, sorry.
28.
Sorry. Yeah, 24, 28.
16 plus 8 is 24. 24 plus 4 is 28. 28 plus 2 is 30, 31, 31 plus 30 plus 1 is
31. But when you are doing the calculation, try to find the easiest combination. Now, since this is binary, so everything is into the power of 2, no? So it's easy to just mix and match. So example, like let's say if you have to calculate 32 and 8, so that means it's, let's say if you had 32, 8, 4, 2, then easiest is 32 and 8 is 40, 4, 2, 6, 46. Try to look at the combinations. You do not have to go through this exact path.
Oh, yes, sir.
Okay. Then now what about the next one?
So it's 128 plus 0 plus 32 plus 0 plus 8 plus 0 plus 2.
Plus
That's all.
0. Okay, so what's the easiest pairs to calculate? 8 plus 2 is 10.
8 plus 8 plus 2.
2
8
is
plus 8
10.
plus 2 is 10.
10.
10 plus 32 is
No,
42.
no, no.
42.
Aripatara. 8 plus 2 is 10. Okay. Then 28.
So let's do the other side. So
Yeah.
28.
28 and 30.
28 plus 2 is 130.
30.
130 plus 32. It is 162. 162 plus 8 is
162 ආවේ කොහොමද?
32 is there.
හරි මේ 32 එකේ දෙක ගන්නකො ඉස්සල්ලා දෙක අරන් මෙතනට දාන්න. So then what would happen? This is 130, right? Then you got the 2 from 32, no? So then 130 plus 30, 160.
Answer the other two. The other two.
Yeah. Oh, මෙතන 160 and we have 8 and 2, that means 10, then 170.
Yes.
අමාරු කරගන්න එපා. Nice. Okay. Then the last one.
The last one is 0 plus 64 plus 0 plus 0 plus 8 plus 4 plus 0 0.
Yeah. What would be the answer then?
So at first 64 plus 4, 68. 68 plus 8. The answer is 76.
Nice. Perfect. Nice. Okay. That's good.
Thank you, sir.
Alright. Okay. Wake away. Okay. Yeah. Perfect. So then we have a question. So this is asking, why is the maximum value of an 8-bit sequence is 255?
Let's focus next.
Okay.
Why is 8-bit sequences 255? So in this is no idea, sir.
So when it comes to 8 bits, the maximum binary number, when you add them all together, the maximum you can go is 255. So just okay, so let me show you how it works. So simple, just add the values together. අපි ගමු මෙතන 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. You got the idea? 255. So when you add the binary numbers together, the maximum value you can get out of a 8-bit sequence is 255. So if you get the question, just write the total numbers. You can say the maximum value, the reason the maximum value you can get 255 is that when you add all the numbers together, that is what you get.
Now I understood, sir. Thank you, sir.
It's just a matter of adding the numbers all together.
Yeah, sir. Sir, can I write like this? The reason the maximum number of 8 bits is 225 is
255,
the
55.
255.
Yes.
255 is because all the binary values add up to 250.
Yeah, if you, it would be nice if you can just add them. So since you have like three rows to provide the answer, so just write it, just to just show the world that you know
Yeah.
how it's created. Okay, now we jump into another very tricky question: conversions. Okay, so yes, how can we convert this now?
2, 3, 4, 5, 6, 7, 8. Okay, 8, 9, 1 plus 3. Wait, sir, I'm just going to do it.
You have the table on top, by the way.
Yeah, sir. I can remember exactly the correct bit in the correct point.
Perfect. That's perfect. So, Kevin, now when you're writing the answer, so write it in a proper way where you just write the numbers again. Na? So, similar to this one, we wrote the addition. No? So, write the same answer here as well. So, start from the beginning. So, this is an 8-bit sequence. Ne? So, we know this is 128, then 64, 32, 16, 8 likewise. Ne? So here it's better if you can write this. So here 0 0 you don't have to write, so you can just write 32 plus, then 16 plus 0 0 you don't have to write, again 2 plus 1. What is the answer?
So the answer is 51 base 10.
50?
51 the base 10.
Correct. Yes. What about the last one?
Let's say 1, 2, 3, 4, 5, 6, 7, 8. So that is 8 bit.
Yeah, same thing.
3, 5, 6, 7, 8. Those are the answer. And 1 plus 0 plus 0 plus. Plus 8, 9. Let's have 8.
Okay.
9.
Are you writing the same answer which I am looking at?
Oh, yes.
Okay, so what's the answer?
Where is it? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. The 153 the best 10?
Yes, 153. Okay, nice.
That look like 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay.
Everything is 8 bits, huh?
And it should be 1, 2, 225.
2 what?
255 is it? if it's equity.
No. So, no, I didn't get your question, Kevin. No, what do you mean?
Sir, in this one, sir, in this binary, sir, just count 1, 2, 3, 4,
4,
5,
5, 6,
6,
7, 8.
7, 8.
Okay.
And sir, then the total should be sir 255, sir.
No, that is if we have all ones.
No, sir. Normally, sir, in these things, sir, in the top, sir,
Okay.
there is a table, no, sir. It is also 1, 2, 3, 4, 5, 6, 7, 8.
Yes.
So, sir, there should be 255.
So 255 sums up when you add all the values together.
No.
Ayyo, hold on. It's like this, no? So 255 comes up 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1 equals
Now,
212.
okay, sir.
So for this question, this is the answer. You have to write this one. Y is the maximum value of y is the maximum value of the sequence. You'll have to write. That is because when we add up all the decimal numbers together or the denominator numbers together, we get 255. That's the maximum amount which a binary 8-bit binary can go.
Okay. Thank you, sir.
Got the
Now
idea,
I
right?
understand.
Okay.
Yes.
So similar to this, these are also remember to write your workings, huh? Because if you directly write the amount as 51, I'm pretty sure you're not going to get the full marks. So the answer,
Yes.
that explanation is a must. Okay, nice, super. Now we jump into a question. Can we try to, so before you go to the exam tomorrow, try to just do few more conversions and see. Practice few more
Okay.
conversions. Okay, nice. Okay, let's quickly jump to this table. So, which of the following is another word for dinery?
Another word for dinner. Decimal.
Yes. Then, what are base 10, base 2 and base 10? Both examples of?
Binary systems and decimal systems.
Yeah, but you can't put two answers, no? It has to be one answer.
Number systems.
Number systems, exactly. Yes, we call them number systems. Nice. So then, how many colors can an 8-bit graphic contain?
255.
Correct. Be careful. No, nothing to do with 256. Huh?
Okay.
It always goes until 255 because that's the maximum binary limit. Nice. So using base 10, what is 10 to the power 3 equals to?
10 to the 1000.
How did you make the calculation?
10 times 10 times.
Yeah, so that means 10 into 10 into 10. Nice.
Yes.
Perfect. And what is 2 to the power 4 equals to?
2 to the power 4 equals to 2 to the power 16, sir.
Yes, correct. Nice, perfect. You're all good huh, with the numbers. That's
Thank you,
perfect.
sir.
But when you're giving the answers, take your time, huh? No rush. Because you would be getting 1.5 hours, 1.5 hours or 1 hour, the paper.
1.5 hours, sir, probably.
Probably 1.5. No, so yes, take it slow.
Depending on the page numbers and those things.
Okay. Yeah, that's cool. Okay, so then the next one. Give the 4 steps of how to convert a number. Convert a binary number to binary using the divide by method.
Divide by 2 method.
Yeah. divide by 2 method. Sorry, divide by 2
Okay.
method.
First we have to take the denary number, and after that we have to divide the denary number by 2.
Okay.
And if there's a remainder,
Perfect.
or if there's a remainder,
Yeah.
we should put 1 in the side. If there's no remainder, we should put 0 in the side.
Perfect.
And after that, end of the calculation, we get 1.
Yeah.
With that one, we make our binary digit all okay.
Yeah, perfect. So, perfect answer. Remember, the keyword is the divide and the remainder. Okay. So,
Okay.
yeah, the remainder is the main keyword. So now the divide by 2 method, what we call this is we call it. So these are the 4 steps. So, if you can write this down, Kevin, it would make it easy for you to remember. So the divide by 2 method. So what you said was correct, perfectly correct, but you have to write it in steps because it is asking specifically for the steps, no? So you have to make sure that you know the steps. So the first step is divide the denary number by 2 and write down the remainder as 1 or 0. So what you said was perfect. Then the point you missed was the second one. So you have to say that to repeat the process until there is no longer a whole number. Okay. So you have to repeat. So Behema, you don't have to tell this in the exact way. If you say that keep on dividing until you don't get any number, so until you reach 0, that is perfectly fine. But remember the keyword. Repeat this process until there is no longer a whole number. A whole number කියන්නේ divide කරන්න පුළුවන් number එකක් නැති වෙනකන්. Then the third one is now you have done the dividing part, no? So then the third one is you write the remainder digits from right to left to make the binary number. So from right to left, or right in left because we take it from down to up, no? So that means you write it from right to left. Okay, and then the fourth one would be checking by adding together the place values. So the place values is what we learned before by when we went through that binary table. Okay, just to practice this, can you write this down? Okay, read this and write it down in your own terms. But remember, these are the keywords. So the divide is a keyword and the remainder is a keyword, and then the repeat is also a keyword.
Okay, sir.
Okay, Lian, go write it down.
Sir,
Yeah.
I have one question. Like they ask sometimes write the decimal or convert binary into decimal in the place value.
Yeah.
What is that?
Yeah, so the place value is basically what we learned here. So, go. See, these are the place values. This is what we known as place values.
Okay, yes, sir. Like what are the steps? Like I didn't know.
Okay, so okay, so the same. Okay. Sorry. Now I got your point. So this is what we call as converting it using the place value. So see, we have the binary numbers, we have the decimal numbers, the denary numbers, and we convert it using the place values. So here it's 1, we put 1, 2, we put 2, and likewise.
Sir, it is like converting binary to denary. When we are converting denary to binary.
Yeah, from converting it the other way around, then it goes like this. So this would be now here what we call as place values is the particular remainder we get. So these are the place values. place values කියන්නේ හරි නිකම් simple විදිහට බලන්නකො place value එක කියන්නේ අපේ binary value එක අපේ decimal value එකට තියෙන binary representation එක. So when we take the binary table, the place value is what we have as ones and zeros. So in this case, when you divide this is the remainder. But the thing is here you have to you start writing it. So if you are I'll give you a quick pointer now. If you try to write this from top to bottom, then you have to start writing it from right side. So what I always tell you guys is start writing it from bottom to top, so that you can start writing from left to right. When you do
this side, right? From here to here, if we start from here to here.
Yeah, so if you start from the top, then that means you have to go from left to right. If you start from here, if you start from here this way, why is this? Hold on. Yeah, if you start from this way, then you have to write right to left. But if you start from bottom up, then you can go left to right.
But I write the other side, listen.
Other side in the sense, which one do you use?
Like I
One
write
or
from
two?
like if we start like 1 1 0 0 1 0 0 1.
Yeah, so that's the easiest way to remember it. So go from bottom to top. Now here, yeah, here it says write the values from right to left, no? So that means they are saying come from bottom to from top to bottom. වමේ දැන් මෙයා කියන්නේ දකුණේ ඉඳන් වමට ලියන්න කියලානේ, from right to left කියලානේ කියන්නේ. එතකොට if you are writing it from right to left, you have to come from top to bottom. So
sir, I go from down to up, sir.
yes, exactly. Bottom to up, exactly. So when you go bottom to up, it's easy because then you can write from left to right.
Yes, like from starting from the down. We can.
Exactly. Yes.
So they have written it in the other way, right? So, but if we write from bottom to top, also anyway correct, right?
Whatever the way it is, yes, it is correct. But the thing is now, like now normally when it comes to academics and when we go through the theory, we follow the right to left pattern. So that basically you go from top to bottom, where you start from right to left. But ඕක අමාරුයි මතක තියාගන්න. ඊට වඩා ලේසි යටින් ඉඳන් උඩට යන එක. You can go from bottom to top and you write from left to right. That's easy, no?
Yes.
හරි. මේ can you just write this in your own words, this particular part? You are on mute.
I didn't know, sir, how mother is trying to make me sick.
Why?
No, sir, now I got severely asthma, sir. Like now I got cough neck, and she's like asking, are you having like so much or little? And I don't want because I don't have.
Okay, so just so Kevin, write it down in your own words. Quick.
Okay, sir.
Yanna ban, I need to jump. I need to jump out in a while. Man. I'm recording this video anyway. I'll upload and give you the link as well.
Okay, sir. Thank you, sir. And sir, one main thing, sir. Sir, this time, sir. So this time, sir, so did like more than the limit for the month, sir. And
Ayyo,
sir, our
no.
mother is asking like
No way,
may
no
like
way. No way.
mother.
No problem, no problem. No, no, that's perfectly
But
okay.
sir, it's not good, sir.
No, no, that's perfectly okay. That's perfectly okay. We don't think about that. Let's finish it off. We still have a few more complex things to cover up. So binary. So the binary numbers thing, 8-bit binary numbers. Okay. Now here, this is where the thing comes in a tricky way. Now here, now this does not ask you to show the conversion. Okay, so this doesn't ask you to show how you make that what do you call it, the dividing part. Okay, so because of that reason you can directly write the answer, that's perfectly fine. But when you're getting the questions Kemit for the exam, obviously I'm pretty sure they might ask you to show the findings. So if that's the case, you must write down the way you have done the calculation. Okay, so this is particularly has to be done, otherwise it's going to be a you might lose marks, because remember, when it comes to the marking sheets, usually if it is a 2-mark question, 1 mark goes for the for this explanation from the dividing part, and the other mark goes for the final answer. So if you put the answer only, then you only get 1 mark. Okay, be careful on that. So remember so read the question, but anyway, may just put the workings. That is easier. Okay, so can we quickly do these questions?
Okay, sir.
What's the binary representation for 21?
For 21, sir, 1, 2, 3, 4. So should we write it in 8-bit binary?
Yes, 8-bit binary, but
They have
cool.
given 4 spaces.
Oh, no, they have given only 4 spaces. So for the first, uh,
Or else it cannot be sort of.
I
Yes, however, let's do for 4-bit. If it doesn't, let's see if alternative like
yeah, I think
21.
you can't go with 4-bit. No, I mean, you can't even put 21 in 4-bit. 4 bits.
Yes, 21 cannot be because 4-bit only goes up to 60.
Correct, exactly. So
So then be 8.
yeah, no, just write the. Let's just write it. So what is 21?
21, sir, it should start. We should firstly minus it from 16, sir, because 16 is the number that is lower to him, lower to the number, and that doesn't exceed the limit of the number. So, firstly, we can minus 21 minus 16. 21 minus 16 equals to.
May if you are going with the workings, then you will have to show the dividing order. Nattam bad. So you will have to write the steps.
So these things, no?
Yes.
That. You should make it like that.
Yeah, so we will have to write 21. So what would be the first thing? So it would be 21 divided by 21 divided, so I'll write divide like this, divided by 2, right? So
It cannot be said. It should be 10 and 1 remainder.
exactly.
21 equals to 1 remainder, and 10 is the thing next we go.
Yeah, so 21 divided by 2, which you get 10, and you get a remainder, right? And then you divide
2
10,
remainders, 5.
10 by 2, 5, so that means 0. Then 5 divided by 2, again
1 remainder 2.
1 remainder, yes.
And 2.
Nice. So
That all that website, sir, but I didn't use it. I got it.
okay, so ideal situation, Kemith, you will have to write this process like this. So 21 divided by 2 equals 10, 1 remainder, 21 divided, sorry, 10 divided by 2, 5, 0, no remainders, 5 divided by 2, 1 remainder, 2 divided by 2, 1, equals 1, 0, no remainder, and 0 divided by 2, again, you get 1 remainder, right? So that means it would be 1, 0, 1, 0, 1. Okay, so let's try out the other one as well. May you have to practice, sir. Make a karanda morning. So I'll put the answer here. Then 48. So let's try.
48 we can use.
So 48 we divide by 2, which is 24. Then 24 divided by 2, 12. 12 divided by 2, 6. 6 divided by 2, 3. 3 divided by 2, 1 with a remainder of 1. And again 1 divided by 2, 0.
Okay, sir. Thank you, sir.
Got it?
Yeah, sir.
Okay, so likewise practice this. So be careful, Kemeth, because this is one. Oops, sorry. This is one thing which most of the children make the mistake where when you get the large numbers, you need to be careful of to show your working, because if you get a number like 200, 243, 243, you have to 243. Oh, let me 243 to
So
by.
isn't it training in your side, sir?
Sorry.
So isn't it training in your side?
It is outside, but it's quite okay. That day it started. It started lightning. I mean, that was so. I think you guys might have noticed that power went out couple of times.
Oh yeah, sir.
Power went out couple of times. Then that's the reason I stopped it, because so the Wi-Fi signal is not that good. So I do have a network cable directly plugged into the laptop. So I don't want to take a risk during the lightning to have a network cable plugged in. Okay,
Yeah.
so let's.
There is even striking in our side, and our brother got just scared of that.
Okay. Okay. No, just let's just go through, because I also need to jump out in a while. In few minutes I do have another meeting actually. So okay, so now be careful, Kevin. These are the tricky questions where you have like large numbers. Anyway, don't worry, you will not get questions more than 8 bits. So the maximum you are going to get is 255 within that 8-bit range. So don't worry about it. You will never get more than that. But then again, when you're writing the answer, be careful. Like when you're dividing something like this, be careful, divide it correctly. Okay, so you don't get to use calculators also. So be careful, and the working has to be there. So 243 divided by 2, 121 with a remainder of 1. 121 divided by 2, 60, again a remainder. 60 divided by 2, 30, no remainders. 30 divided by 2, 15, no remainders. 15 divided by 2, 7, 1 remainder. Then all odd numbers goes on, so it's all ones. Okay,
Yeah.
and so I do follow this trick when I'm kind of working on this, because if you get once you get up to the level where, like, let's say 7 ish, then you can just add 4 ones. because 7 is a odd number, no? So all the rest of the numbers will be odd numbers.
Yeah, sir.
Okay, so Hari, okay, let's quickly jump to the next one. So here we do have the divide by 2 method. This is not a serious question. This is just asking to write the details. Is it thundering that much?
So I'm scared of thundering, sir.
Okay, okay. Super. So, okay, then what else? Yeah, you might get questions like this also. So here, this is basically a question which is halfway done. So you have to make sure that you get the base numbers and then divide it. Hari? And okay, and one more point, Kemit. අපි මේකෙන් නවත්තමු. ඔයා මෙන්න මේකත් ලියන්න, මේක ලියන්න ඕනේ point එක. The least significant bit and the most significant bit. Okay? So this was something which we just went through it, but I'm pretty sure you won't remember the point. මතකද මෙහෙම එකක් කරා අපි? Least significant bit එකයි most significant bit එකයි.
Yes, sir, we did it, sir, in the book. They marked it.
Yes, yeah. I think I told you to mark it as well. May remember to go through this point. Huh? So the least significant bit is in the binary. The least significant bit is the digit with the lowest value. Hari, least the lowest value means that is the value which is on the right side. And the most significant bit is the digit with the highest value, which is the value on the left side. Okay, so remember these two. So if you can write this down as well, and okay, Amit, we'll wrap it up. Computer. If it is thundering, you might have to. Okay, just send me a message and tell me how the exam went.
Okay, sir.
Okay.
Thank you, sir.
Super. Okay, then see you.
Okay,
Bye.
sir.
Bye.
Thank you, sir.
Bye. See you. Bye.